We will touch upon that during the panel. So let's start maybe with something what you know, people always like to lament. In Germany, we say always earlier everything was better. I think if you translate it into English, it would be that people lament about the good old days. So today, of course, the times are challenging for everyone in the sector, except maybe the end customer who is happy about low prices, but everyone else suffers, even project developers who see, of course, that, okay, interest rates are coming down now also, but they, of course, see in many markets also that capture rates for solar, so that means the value of solar electricity is going down because there has been so much solar installed, curtailment rates are going up. So it's also not easy to get financing because there's no visibility also how the sector is evolving. Nevertheless, of course, the market growth simply because there's so much demand for solar, because it's so versatile, and because, of course, there's still so much untapped potential. I think it was great that Amit showed this carports. I think there's not so many of these around. I think there's need for that with electrification of the energy sector, but again, we have a long way to go. Nevertheless, so if we compare today's rather challenging time, maybe if to 2 years ago when we almost lived in days of plenty, so that means the supply chain challenges had been sort of solved. Material was there, and product prices were high because of the energy prices. And actually also when we look at maybe 5 years ago when the global market was, I don't know, 5 times smaller or so. So what did module manufacturers and product manufacturers do different at that time? We heard already about automation. I think GCL said it's great on the one hand. I think URQ pointed actually that it could also cause some problems. So maybe everyone. What's different, or what was different or better in the past, and where can we still learn from today and in these challenging times? I don't know who wants to ask first, say something first, and maybe also to the audience. If anyone feels to contribute something, please write into the chat, and I try to include that into our thin red line here on the panel.
Well, I mean, like I can start maybe, Michael, since you know I've been in the industry for a while also, and I would, first of all, I wouldn't agree with the statement then that in the past everything was better. I think ever since I've been in the industry, I can remember challenges, ups and downs, and technology advancements almost always also brought additional risk. So, I mean, now we went from, you know, one cell technology to another. We went to bigger modules, and that brings challenges. Last 2-3 years, maybe a lot of changes came at once. That's maybe a difference. But in the past, we went from thick cells to thin cells. We went from you know, one cell technology to another. Also, we had a lot of thin film modules with issues, and we had a huge industry-wide backsheet issue, not to forget. The difference maybe is now the industry is so much bigger. So if there is a serious defect that affects multiple suppliers, very easily we have many gigawatts of faulty products somewhere out in the world, and the scale of a potential quality flaw is much bigger today than it was maybe a few years back.
Anyone else?
Yeah, maybe I would like to add that just from the system, if the market pressure is so high, so first company brings out a TOPCon module, so all the other producers need to have a TOPCon version as well, and then testing it takes time. That's the first issue, and it costs a lot. So under this pressure, it's not easy for manufacturers, I assume, or I know from one by one talking, to test a product till the final end and to do an extra X course and maybe check for that and check for that and check for that and do an improvement circle before you actually bring it to the market. So I think because they need to, and it's important to bring out the new project and the new round of a product as early as possible. And so I think this has an impact on the quality of modules, or can have an impact of quality.
Maybe I can also add something. So first of all, we should understand that in the past years, there were some advancements which really helped the reliability of the modules, but there were also market pressure. We should also consider that lots of decisions at the end comes because of the market. For example, in the past years, by increasing the shipping costs, especially during the Corona time, we saw that the frame thickness was decreased, that you can ship simply more modules per container. And it was simply a decision which was a pressure from the market, because if you were insisting to have that, you were losing the market. So we should understand also it's not always the advancement of the components and from the manufacturer side, but also a lot of pressure coming from the market, which can influence decisions and change of the bill of materials.
Yeah, in my opinion, I agree with George from SEA. I think at every moment we have the challenges from the real-time world, I think. So like 5 years ago, we were focusing on the encapsulation solution for the PERC bifacial model and the anti-PID issues from the backside of the cell. And like 2 years ago, when TOPCon came into the market, we focused on our solving the anti-PID issue on the front side of the TOPCon cell. So every time when the technology develops, we try to adapt to the new technology. So I think that is always the case.
But I think so. The technologies are not new. Okay, it takes a while until they come to market. But I think TOPCon cells were invented in, I think, 89 or something like this, and then of course it took a while. Why is it then still so surprising that these things come up? You know, I think so. When we looked at TOPCon when it started actually, and of course companies were still using EVA and not POE, and so it's I don't know, why do we have to kind of stumble upon such things? Because there has been plenty of times until the products came to the market. So all the cell technologies that are out there are basically well known for decades, right? I think maybe tandem will be a bit different, but even there, I think a couple of companies are now working on this for quite a while, huh?
Well, Michael, I mean, you're right. It's the step to take an R&D product into mass production, and then also doing the cost assumptions and using the materials that make sense in the mass production. That's where you need to verify your design finally through reliability testing. And here I think shortcuts are being taken because of the cost pressure. People are just wanting to take the better product out sooner the door, with cheapest as possible bill of materials. And history has shown in this industry many times that issues still happen, but that could have been avoided with thorough reliability testing upfront. So it's unfortunately also learning from the issues in the past and doing the preventive actions upfront is something that still from time to time taking shortcuts here.
Ahmed, you've been working long also at the a research institute, and now you're on the manufacturer side. And I think it was great also that you showed that example of this carport application. And the first question was also, or the only question that came actually was regarding certification. And then you have the product, but it takes also a while to get that out. So how are you dealing with that pressure? And of course, pressure is even worse now than it has probably ever before, because we have all these overcapacities now, and companies just throwing their products on the market.
Well, yeah, I would say that our sales director is going to be very happy with these questions. They're pretty much always putting pressure on this point. Yes, the certification is a big challenge because, first of all, we have to consider some general certifications like what we have, like IEC 61215 or the 61730. These are standards that everybody should do, but the point is that there are regional certifications. For example, if you want to go to France, if you want to come to Germany, if you have a different application, so there are many of them, and each country is responding differently. For example, some countries are highly bureaucratic, and it takes ages that you want to do that. But the point is that you need also to be fast. So the PV market is a really, really fast market. So I would say that we so far haven't really found some solutions on it, so that we can accelerate these testings. We do the tests, we do the certifications, but actually bureaucracy, especially from the testing sites, are most of the time is really killing us. So this is really, really pushing back status, but I would say that it's mainly should come from political point of view for each organizations and test centers that could also help us to come with the product faster to the market.
Yeah, you've been working at TÜV for a long time, and of course, Ingrid, you're also in this field. So what can we do with these challenges? So with all these quick developments in technology, and I think it was incredible what happened in the recent years with modules getting bigger and bigger, and cells getting bigger, and then actually also having different cell formats. In the beginning was pretty easy with M10 and G12, and then all these hybrid forms popped up. What are we? Is the industry and those involved in certification fast enough to also guarantee that the industry can do its job properly and produce high quality and reliable?
Maybe I can shortly comment on that. So first of all, this is also a big challenge, because we see also from the research centers and some test centers as well that they are not fast enough to adapt themselves to the industry development. So this is a big challenge. So most of these research institutes are funded by governments, which are also bureaucratic, and until, for example, and even a new technology is coming, it requires more requirements from the whole supply chain. When a new size of solar cell comes, means that you need a new stringer, you need a new device for measurement, for the sizing, etc., etc. So time to time, we see that there is a very big gap between the time that the research institute can procure this measurement tools and the time that manufacturer has brought the technology to the market. So this is also a big challenge, because it makes the testing through third parties quite difficult.
Yeah, I would agree on that. Like the classic example was the IAAA problematic with the back sheets. Like there was no test sequence which could outbring the failure, and so it happened in the field. All the modules had an IEC certification, but still they failed in the field. And then it took, I think Janno Oreski once gave a nice talk about that. It took 5 years until there was a new norm, a new IEC standard, which now focuses on testing specifically failures of backsheets. And that's a long loop to go. And we as testing labs, we cannot guarantee that we find all failure mechanisms at the beginning. We learn, we have customers, they give us modules. When we see specifically at Fraunhofer, we also try to do in-between characterization. We develop our own test sequences where we have the feeling this could be difficult. We have a cell development sitting next to us, so we can also go to them and ask them what is critical about that cell technology or what not. But most of the things, as explained beforehand, are not intrinsically in the cell technology, but maybe from the embedding, from the commercialization process. Yeah, it's just being clever and being quick and finding the right tests for the right failure mechanisms. That's a challenge, and it always stays a challenge. Plus, we can't just test everything. That would be the dream, but no one's going to pay that.
But when of course testing institutions are also in competition with each other, and everyone is also coming up with different sets and different labels. Of course, it's also a business, right? How much does that help? Okay, competition is good because of course then the one or the other is going quicker. But how are we in a healthy competition? Is that going in the right direction? Also, we're seeing testing institutes are merging and getting bigger, are taken over. I think Clean Energy Associates was also taken over recently by a big institution. We saw yesterday, I think now recently they were still called PI Berlin and PWEL. Now you have the big Kiva on top of that. And soon they might be only Kiva and there might be no PI Berlin or PWEL anymore. So is this the right direction or will this slow things down?
Well, Michael, I think first of all, I would like to state and separate the discussion about certification and reliability or research, because the certification should be the last step you take your product to. You should know your product very well and have it fully reliability tested before you take it to a certification agency. That's first statement. And in terms of reliability and the situation where we are at, taking also your comment before, was everything better in the past? I think now, no, we have now much more educated investors asking much more questions, and it's pretty much standard for a large scale system with tens of megawatts now, that there is a financer or an investor asking for detailed reliability reports exceeding IEC by many times. And in such way, I think something like the AAA wouldn't be in the same way possible, because there is somebody testing 3 times IEC of a product and something will surface. But of course, we also don't understand all the mechanisms up front, and looking at UVID at the moment, that is a big discussion. There's still a lot of uncertainty of what is the magnitude of the problem and is it all curing itself again or not. And so there is research needed, and research takes time. The problem is more so that the certification standard is checking for a minimum requirement based on the past history, and making a new finding into a new standard will take many years for IEC or whatever. It's not even the investment missing from the certification departments. It's more the standards lacking that take time.
Okay, then let's maybe, yeah, sorry, please go ahead.
Just in terms of advice, I would say when there is a change in technology, something new, questions about the reliability testing must be asked. Okay.
So then let's maybe look at, because we talked a little bit about the past, so that not everything is always better. That's for sure. Even if the some sayings say so. But what do you think were the major achievements towards higher module reliability that were reached in recent years? And yeah, so we just look at what has improved actually reliability most. And I think it's maybe an individual perception, but what do you see?
I can take that if you want.
Huh?
Okay, so I mean, there's many things, but one thing I've just mentioned is that more questions are being asked, and quality assurance by third party is a standard for large scale projects. So there is more of a independent look on a supplier's fingers, if you want, at least for large scale installations. That's not true for all the market. And in terms of technology, while there's huge cost pressure and need for change, there's also a good understanding now how a cell needs to be protected, and so much effort has been put into developing better encapsulants and better packaging of the modules, which in the past it was standard. It was glass, EVA, and cell, and there is so much more research gone into these individual components. I think in general the packaging and protection against environmental impacts has improved.
Mm-hmm.
Indeed, maybe I can have some on
COVID.
So basically, some technological advancements, such as shifting to N-type solar cells, is very interesting because it's already eliminates some of the known defects, such as LID that we had previously in PERC technology, P-types. And more we see that the encapsulation of the modules goes toward PoE, which shows a better durability compared to EVA in many cases. And by considering that we have the solar project not only in one location, but all over the world with different climate conditions is very important. And one of the highlights, I would say, that the half-cut cells, because it brings not only more CTM to the module, but it brings also more reliability because of the cell sizes and cell displacement in the module.
Yeah, from the material side, from the material perspective, for example, when we talk about the reliability, if our customer requests their key focus is the reliability, then I think PoE material is always our first recommendation, no matter this is for PERC or N-type model. And of course, some customers, they have to consider the reliability as well as the cost down topic. So in this way, I think they would choose a harmonized solution like EPE. So this is the case from the encapsulant perspective. Yeah.
Good.
Yeah, maybe I would just add, like, from the module design, I'm not so sure what brought the biggest improvement in reliability, but I would like to stress again the point that I feel like the quality assurance is happening now on site of the EPCs. They ask more questions, they test more specific. They try to bounce it back, I think, as well, back to the module producer and say, you're gonna pay the testing, we give you the sequence. But yeah, so this is, I think, and it's also that bounces back to the question of yours, whether how I find it that there are more and more testing labs. I think it's a good thing in the end if there's more testing, and if testing gets cheaper in a way. And I do consider all the testing labs I've been dealing with as good and qualified, and we know each other. So I don't think that there's much of a risk of bad testing. And the more you test, the better the quality is. That's yeah.
Okay. And so but still we're seeing, of course, with this cost pressure that's simply there in the market, and I think over the next few months that won't change. So I just checked that our module price index, I think module prices in China have again decreased a little bit, actually, at least certain parts. The N-type parts went down again. I think there was a concerted approach actually to get wafer prices up. Wafer prices went also down. I think there's now an effort from the Chinese Photovoltaic Industry Association to bring in actually a floor price for tenders in China, so that that they can actually somewhat stop the fall of module prices there. But so in any case, I think it doesn't look like the situation is changing rapidly. There's simply too much capacity, too much players on the market, too much pressure actually to get also product out to get at least some revenue. Even if you have to make losses, we're also seeing that companies get innovative to get new cash in. Yes, there were a couple of announcements for big Chinese companies to do IPOs in Europe now. So everyone is really trying hard, and it's as much as it can to stay alive. So what can we do actually in these days actually to that reliability is still taken seriously, careful? So I think we heard, of course, from big module manufacturers that there's no compromise on quality, because it might fire back, but companies have to work on that. And JA also yesterday said clearly we have to look into new cheaper solutions, whatever that means. They gave examples like zero bus bars or other things, different frames. So I was in the US. I saw actually some companies now kind of exhibiting modules with steel frames instead of aluminum frames, because they could save on costs there. So what can the industry at the moment do in these challenging times to really make sure that reliability stays on top?
Yeah, maybe I can start. Yeah. So yeah, I think the cost down is a lifelong topic for all the industries, not just for the PV market. So of course, the PV module makers, they always would like to reduce their production cost and make their product cheaper. But it only makes sense when the reliability is stable, it is guaranteed. So they, of course, have lots of technology to build their module, new technologies, for example, like zero busbar technology, etc. And they also have more and more requirements to the raw material suppliers like us. So we are having lots of, how to say that, the test and also try to develop new recipes for their new requirements. So it is always going on. So in my opinion, yeah, no matter what is the price, the reliability is always the topic, and the module makers are really care about the reliability. So I think we are, how to say that, always paying attention to the reliability topic.
But I think you showed also in your presentation you have POE and then you have an economic solution. Are you seeing now that companies go more and more at the moment to the economic solution because the price pressure is so high, although they would prefer maybe a different one, but that's simply not doable?
I think both, even for the economic solution, it could meet the basic requirement of the reliability. That is for sure. But some companies, maybe some module makers, they consider more about the reliability. That's why they would like to spend more to have higher reliability for their product. So both solutions are actually meeting the basic requirement of the reliability. Maybe I didn't explain that very clearly during the presentation.
Maybe I can add also something here, because we need to understand, first of all, again, coming back to the market before we come to the manufacturer. many countries that they are implementing large PV plants, they are highly price sensitive. So in case that the price of the module, so I maybe might not be agree with Jin about that, that no matter how much the cost, because the higher cost of the material leads to a higher cost of the product at the end of the day. And unless that you do some optimization somewhere else, but when the product is more expensive, we need to understand that, especially in these price-sensitive countries, the people who buy the modules are procurement people. They're not technical people. So they look at the price and they look at the basic certifications, and they make the big decisions based on these two. So this is very important to keep a good level of reliability with a good optimization and costs. So otherwise, it will be very difficult to sell everywhere. Of course, in some countries, when we have more educated EPCs and investors, they are willing to pay a bit more for the premium. But if you look at the reality, 0.001 cent can change the deal in large size projects. So it's very important to maintain both reliability and keep the costs down. And of course, you have to find a kind of optimization in solution in between. And we have to also understand that these days we have quite vast areas that they're implementing PV plants in the desert, in the highlands, in alpines, in tropical places, everywhere. And each of them have a different reliability and durability requirements. So even on the sea, and this is like one side of it, that manufacturers always try to, of course, address these points. But also other side as the EPCs, I think that to achieve a better reliability for the module, we shouldn't always focus on the manufacturer. We should also focus on the complete chain of the installation, maintenance, and reliability, and even monitoring, misusement of the PV module, abusement of the module. So these are the things which happens later than the module production, and it's anyhow part of the reliability of the project in the system. But it might not really can be answered by the module manufacturer if a person walks on the module, jumps on the module, drops them, or mount them in a wrong way, especially with a lot of pressures from the market about the mounting systems, where you and how you mount the solar system from the short side, from the large side, from the corner. Of course, it affects the durability of your panels.
Well, Michael, if I may add, so I think, I mean, reliability you can test for with very long and costly test procedures, but you can't do it on a project level because you know it takes too long. So that's one thing. But what you can do on a project level is take care of stringent quality control, and quality control is the basis for reliability. Going back to the example I showed of the junction boxes running hot. And when we're talking about soldering a tap to a copper piece, it's not rocket science. The only thing it goes wrong is because quality control is not good enough on that piece. So we still see that that you know, depending on how closely a client looks on what he's buying, does decide if he's getting a better quality product or a not so good quality product. And so having the pressure from the market on quality is definitely helping improve the reliability on the supplier side. So also, for example, when we do QA work at the suppliers appreciate it because also they find issues and they can solve them.
And then how much is it actually then needed? Because you have your people also standing in the factories also, and making sure that that the supply is correct and the correct materials are being used. Are you seeing today changes compared to a year ago or so, or when the situation was not as dramatic as it is to now?
I don't know if we have time to go into the details, but we've just released the quality control report. But one thing is that whenever a third party comes on site to do quality control, it does it against a contract that is there between the buyer and the seller. and the contract defines the criteria, and some criteria are tighter than others. So it starts in defining what is a good product and what is a not so good product, and that's first needs to be written down in the pass-fail criteria, if you want. And then just being there is the one thing, but taking sufficient sample for testing, batch testing, and so on is another thing, because it's always based on statistics. So you need to, I mean, you can't do 100% inspection on everything.
Yeah, yeah, I agree. Like with the Topcom, like we are asked as an institute, what shall we write in our contract? What are pass-fail criteria to make sure this is a good quality? Or so they ask us for recommendations, and on the other side, we go to a field and we want to get basically understand the degradation. But when we measure the modules, there's already from the beginning a label offset, but we don't know that anymore because we get in half a year later, so we don't know what was the label offset. Then we can't really track what was the degradation, which is it's just not so easy to track it or to know what is a good quality or proof, also statistically and proof, as you mentioned, what's happening and what's a good quality and what not.
Okay, so but Jörg, would you then actually also recommend, because how frequent should testing then take place? Because of course you cannot test each and every module. This is logistically probably not possible, and also nobody can pay for this. So what can we do?
So the one thing is you do the general testing that is done at PSI, pre-shipment inspection, and that's generally done according to AQL level, so very much regulated by ISO standards. When you talk about the test, for example, testing for PID or LETID and things like that, we have recommendations that are based on batches of every 10 or 20 megawatt. You take a sample, or based on BOM variations. If you have things change in your production, there should be some testing done. And I mean, the industry is learning, so some of these recommendations also go down because LID is more or less handled. You don't need to do as many samples as in the past. There is still fluctuation in some tests where we recommend to still continue doing it. So that's based on technology and track record of a supplier. We give recommendations on how many tests should be done per batch or per tens of megawatts.
Maybe I think there's also one question from the chat. So Ingrid, you also talked about the labeling differences. Well, maybe also what are the others seeing there? So do you, well, what's your take on what Fraunhofer found out about this deviation? I think that's at the moment, minus 1.3% in the samples they showed versus their standard.
There's no other testing lab here, I think, or calibration lab. Yeah.
Well, I think it depends really again on contract, because for many buyers, the label doesn't play any role, because they have a contract that is based on flash list or actual power as determined in the factory. Or so contractually, in terms of warranty, of course, the label plays a role. In the buying price, it's not so much decisive. So I'm not sure. I mean, of course, uncertainty, I see a question about uncertainty makes it difficult. Yes, a measurement uncertainty in terms of when you want to make a claim, it's hard, but uncertainties have come down a lot in the recent years. I think Fraunhofer now is proclaiming 1.2% or even 0.9 or something, which is incredible. I've been in PV lab myself, and many years back we thought you couldn't go below 2%. So a lot has changed there. Yeah.
But then, like, being at snack, we are also under pressure. Like even if you say we have 1.1% or something, like if a module has 700 watts, and then they have their binging process, like every 10 watts, you have a different power class. And so they are saying basically, if you have 1.1% measurement uncertainty, that's already covers already 2 power classes, and that's how they sell their products. And so there's a huge pressure from the market that we achieve a lower, much lower measurement uncertainty, which is can only be achieved with a lot of effort as well. Yeah.
Anyone else? Maybe Hamid. So your take on this, or?
Well, I would say that most of the topic was addressed by Ingrid and Jörg. So I would say that from my point, there is nothing much that I can add to it. Of course, the differences in power classes and also measurement tolerance is always an issue. But yeah, from my point of view, I can't really add something on top of it.
Okay, maybe one topic, because I think it's you're the only module maker here on the panel, but I think it would be interesting because you're also somewhat different than the big ones. You really I think you're not small, obviously. You're also in the gigawatt levels, have different factories, and you're in the market for a long time. So you've actually weathered quite some storms, of which we've seen quite a bit over the so you're active for over 20 years. But what's your strategy at the moment to regarding reliability to weather this storm where the end is not in sight, actually? So how is a solar tackling this from the viewpoint of reliability?
I mean, you mean that, just to understand the question correctly, you mean that how generally we tackle the reliability?
Yeah, US, no, and especially in this overcapacity and low price environment, actually, to make sure that reliability stays on top.
Yeah, so this is something which has like different aspects. For example, one of the measures that we took was really think about innovative module designs. Okay, which you don't need to change the bill of materials. For example, with one of our modules, which we considered for vertical installation, we are considering mechanical loading coming from wind or snow, which is significant when the module is vertically mounted. But we didn't change the bill of materials. We just changed the orientation of solar cells and interconnection designs. So with this way, we put the longer side of the module in parallel with the longer side of the cells. So therefore, we had less probability of the breakage of the solar cells coming from thermomechanical stress. This was a very nice also simulation, again, from Andreas Beinert from Fraunhofer ISE, which was comparing actually this design with a normal half-cell designs, that how you can benefit and get a better durability by not changing the bill of material with just rotating the solar cells. And so this was a simple way, so not changing the bill of materials, but a clever design that you can get a better durability on module area. So it was like some of the measures that we do are R&D based, but of course there are some others highly dependent on the proper choice of materials. So as also Jean mentioned, it's not I mean, there are different materials in the market, all of them good for their own market. So I would say that here there is no good or bad material. It's a wrong or right material for a proper market. And since we are, of course, smaller than the bigger brothers in China, we can be quite customer oriented. So in some parts we are doing the R&D, then we are coming for the proper choice of materials and the setup, and of course the quality assurance measures. This is quite a standard. But for us, it's also interesting in large size project to understand exactly what the customer is doing. So this is because, you know, time to time we discuss with customers and we decide not to sell them because we believe that the setup that they have is wrong and brings less durability and reliability for the modules. And considering that the module manufacturer is the only one which gives the warranty, I mean, not with the components, I mean that in the sequence of the project for the. So this is very important for us to understand and avoid wrong setups. So these are the measures that we took to ensure that the project lasts for the investors, because at the end of the day, this is what matters.
Okay. And maybe coming towards the end, a little bit on an outlook. So I just wonder if we might actually also want to take a different view on reliability. So we see these performance warranties of 25, 30. I think there's a few companies who give even 40 years. And if you look at buildings, for example, and especially if we hope that solar really, or anticipate that solar soon becomes the building material, then it might also make sense. But if we look at power plants, there's so much development, or has been so much development actually, that at some point repowering makes sense. So that means that probably most of the modules won't last for 30 years in this power plant anyway. So wouldn't it actually also, because if we want to kind of get costs down also a little bit and adapt to reality, do we have to kind of produce modules that work reliable for 40 years? And I understand, of course, there's a financing aspect, and and that plays an important role why it is as it is. But nevertheless, if we look at the needs and the developments, do we need actually these long-lasting modules?
Maybe I start. So first of all, in my personal opinion, so as a scientist, I believe that 30 years of warranty, I mean, generally for the industry, is insane. Okay, so it's good to have reliable module, but I mean, we have one of the cheapest products in the world, which has the highest warranty term. But regarding to the repowering, and first of all, lots of them are coming. It's a wave of repowering is coming, but there are several aspects. First of all, when you're changing the modules, considering that after some years there are advancements, the module dimensions are changed. The short circuit current rate is increased, the power is increased. So you have to not only change the modules, but you have to change the whole system. Means that you have to rip up everything and build it from the beginning with the proper rated values according to the new panels and new dimensions. So this is actually a lot of cost, and we have to also think about recycling and what happens after the end of life to the PV modules. So this is also very important, because in this case we're producing megatons of trash at the end, which needs also for recycling. This is an absolutely different topic which needs to be addressed. But I would say that from the challenge points, what you're addressing is correct. First of all, for utility scale, is very, in my opinion, more realistic than when people think about a lower time, because the price of land is also at the moment significantly more expensive than before, and the price of module has dropped significantly. So if you can produce more energy per area is always more beneficial. So it might happen that it would be even more beneficial for them to do this, but we have to consider that it's significantly costly, because it's not just the module but the whole system.
Yeah, I would second what Amit says in terms of the longevity of the modules. You know, if you look at a ground-mounted PV system that was built 10 years ago or something, yeah, sometimes it financially, because the modules are so cheap now, it may make sense to do repowering earlier than after 25 years. However, you may need to change the whole cabling because the current is so much higher. And so the most valuable part of an existing ground-mounted system is probably the grid connection that is already there and you have approval to feed in, because that's the scarcity at the moment, to find new locations with good grid connection locations. So there's many aspects to repowering. In terms of an industry responsibility, I think we want to build modules that last long because of the resources we're spending. But having said that, there may be a differentiating factor between the use case of the PV module. As you mentioned, for example, in the building shell, you will need modules that last much longer than if it's really utility scale behind fence, because behind fence also means not everybody can access it. So you could potentially say a module that is behind fence in a utility doesn't have to meet the same safety requirements in terms of electric safety as one that is, in your garden, where everybody can go and touch. And that's the aspect, I think, with this specialization and not having one product fits all markets. You can also think about different lifetimes, different safety factors, and so on. And that's starting to happen.
Yeah, what I would like to add is like that it's not, from my experience, it's not like you develop a module and then this is then designed for 10 years, and then after 10 years it's broken, and then another module you develop for 20 years and then it works perfectly 20 years and then it's broken, right? Like it's always like a degradation, and many failures appear in the first half a year, infant failures basically, and it doesn't matter whether you have a 20 years or 40 years in the field. And we are very much dealing with this topic because we have a lot of vehicle integrated developments and companies you're working with where they have class 3 modules, and this is a whole different aspect. So car companies, they just need 10 years, they never ask for 40 years. And so they asked also, can we change or can we test differently for 10 years? But if you look for a UV dose testing, a standard one, that represents 1 year in Europe, and not even 10. So yeah, so it's I don't think like and the other aspect is like when someone says my module is reliable 40 years, then there will never be a proof, or we as Fraunhofer, we are sometimes asked if we can test it and then basically say, yes, Fraunhofer proved that this module will survive 40 years. We would never do that. No one can do that. That's impossible.
Yeah, I also agree that do not focus too much on the extension of the shelf life of the model. Nowadays, I think more and more module makers are trying to make the raw material suppliers also guarantee giving such a warranty in their material. And from our viewpoint, it is firstly, as you guys mentioned, we cannot prove that in reality. We just did the aging test, the speed up test. But what will happen in the next 25 years, next 30 years, no one knows. And from our viewpoint, it is not just about the raw materials used in the model. The module makers, their process, their treatment would also influence the shelf life of model. So I think not just focusing on extending the shelf life of model, just like you guys said, maybe under different application scenario, the shelf life of the model can be differentiated. Yeah.
Cool. Maybe final question to wrap up. So I think we're in fully in a TOPCon world today. I think we saw that in several presentations that were now PERC and TOPCon has flipped. TOPCon at 70% next year, maybe completely phase out. So we will see. But if we look into within 5 years, we still will be in a TOPCon world. Back contact will probably have higher shares. I think the forecast we saw here from Bloomberg and from others were not so high. I think they were 5-6%. Same thing for heterojunction. But nevertheless, it might be also bigger, especially if Longji should continue and others should follow, simply also to differentiate. We never know what will happen. But seeing also these two new higher efficient technologies, what do you expect actually to see in terms of reliability topics in 5 years from now? So that's one. And second, what in today's situation, what would be the recommendation you give to a buyer actually of modules regarding reliability today?
Well,
yeah, please.
I mean, it's hard to predict what are the failures of tomorrow, but considering that now modules are developed which are in terms of stability, of mechanical stability, in our opinion, very much designed on the edge, like thinner classes and bigger. I'm pretty sure, and it happens already now, that we have more investigations into module breakage and field failures. Also, the how modules are installed, like the sub construction, seems to be becoming more and more important, and like anything which then basically is discussed in front of a court. Yeah.
Yeah, in my opinion, for the next few years, the technology of the cell would also develop, for example, for TOPCon. And maybe for the moment, for example, the glass backsheet TOPCon encapsulation needs specialized PoE, for example. But maybe the technology of the TOPCon cell, it could develop, and later on, it would be possible to use standard PoE or even standard EP or EVA for the encapsulation. That is what we are thinking. And even with such a encapsulation, the how to say that, the reliability is no longer an issue. Yeah, that's our opinion for the coming years.
Okay, so I would say that I agree, first of all, with what Ingrid said in the sense of mounting systems. I would say that it will be a topic, but not only the mounting system, but the effect of the mounting system on the modules, because the price of the module is significantly lower than the mounting system at the moment. So the mounting systems, they don't adapt themselves to the really standard. So you see, for example, in the rooftops, east-west installations, if they are flat, they all clamp in the corners. Okay, this brings a lower reliability for the module because the clamping is in the wrong area. Or some stuff like this, mainly driven from the costs of the panels and comparing it to the cost of the other balance of system components is one aspect. And regarding to the size of the panels, this is really important to understand, first of all, where the panels is going to be installed. So it's very important that the from investor side, they understand what is the right panel. So not a high power panel, but what is the right panel? So it's a question of right or wrong panel and not bad or good panel. So for example, for a windy place, for a place with high snow loads, using always the 700 watt peak modules with large size G12 132 solar cells might not be the best solution. So the panel itself might be proper for other locations, but might not be good for some specific locations. And of course, I showed also the picture with the simulations that as much as you increase the width of the module, the reliability will be decreased drastically. So these are, I think, that the main issues I'm going to see in module level, but also considering that topcon and heterojunction degradations will remain a big topic, especially considering the humidity on heterojunction, which is quite sensitive. Also, we see that also on topcon. So I would say that the main things that I'm going to see in the next 5 years, apart from the perovskite and tandem story, is these parts.
Well, I would add that knowing the location of your site and finding the right product for it is crucial. We all heard about strong weather phenomenon increasing, and some plants have been hit by hail, and originally everybody thought glass module is tighter for hail than the traditional glass backsheet. But truth is, it really depends on what's the right choice for a site. If you're building a PV site where you know hail is something that's going to come, you need to choose another product. Otherwise, fatal damage is likely. And in terms of this, I'm just trying to point at reliability is one thing, but you need to combine it with what is your expected stress, and it's not the same everywhere.
Okay, thanks, Jörg. That were great final words. Thanks to the panelists. That was very insightful. Thanks a lot. Thanks to the audience staying with us over 2 days. Thanks to the sponsors for supporting us. And last but not least, thanks a lot to the Taiyang team in several countries supporting this event. So just 2 things I want to point at. So we have our reports actually. This one is on solar trackers we published recently that can be downloaded free of charge. A couple of others are pending. I think we are at the moment working on the backsheets and encapsulation market survey that's due soon. And our next event will take place on November 19th, so in a month from now, and we move from the module which we consider the heart of the system to the brain, and I thought a lot about that, the mitochondria of the solar system, which is the battery. So we really want to look into trends, technology trends and application trends for inverters and batteries. Thanks a lot to everyone participating, joining, and I wish you a nice afternoon or evening, and see you soon. Thanks.
Thank you very much.
Thank you.
Thank you. Bye-bye.
Bye.
Stay charged.